Welcome to Serene Science, a place for stressless learning. In this video, we're going to practice balancing chemical equations. We must balance chemical equations because of something called the law of conservation of mass. From that law, we must have an equal number of atoms of an element on both sides of a chemical equation. Here's a guide that's going to help us as we work through some problems. This is just one way to approach balancing chemical equations. Everyone's brain works differently, and this may resonate with you or it may not. If not, I encourage you to seek out other resources and find something that works for you. But here's the general steps to our guide. We're going to start by balancing the metals in our equation first. We're going to follow that by balancing nonmetals, except for hydrogen and oxygen. And then we're going to balance our hydrogens after that. And then in the final step, we're going to balance our oxygens. So let's take a look at our first problem. To get started, I'm going to take an inventory of the atoms that are present as written on the screen right now. So I'm going to track the reactants and I'm going to track the products. As written right now, there's one magnesium on the reactant side and there are two oxygens on the reactant side as well. On the product side, I have one magnesium and one oxygen atom. Just as a reminder, the reactants are to the left of the arrow and the products are to the right of the arrow. As you can see, our numbers are not equal on both reactant and product side for oxygen. Right now, magnesium is okay. There's one of each on the reactant side and the product side, so it's balanced, but oxygen is not. I have two oxygen atoms on my reactant side and only one on my product side. In order to get this to be balanced, I'm going to put a coefficient of 2 in front of my product MgO. When I do this, it's going to increase the number of oxygens on my product side to 2, but it also increased the number of magnesium atoms on my product side as well. That is now increased to 2 as well. So I was able to balance my oxygens, but I unbalanced my magnesium in the process. So now I'm going to go back to my reactant side and I'm going to put a 2 in front of the Mg for magnesium. And this gives me 2 magnesium on that side. So as you can see, adding those coefficients allowed us to have the same number of magnesium atoms on the reactant and product side and the same number of oxygen atoms on the reactant and product side. So this reaction is balanced. I did leave a blank space in front of O2. That blank space represents an understood 1. We don't usually write 1s in balanced chemical equations. Let's try another one. So I'm going to start by taking an inventory of my reactants. I have one carbon atom. I have 4 hydrogen atoms, and I have 2 oxygen atoms. I'm going to do a similar thing for my product side. I have 1 carbon atom, 2 hydrogen atoms, and I have 3 oxygen atoms on my product side. So now I'm going to go down my list and try to make sure and get every atom to be balanced. The carbons are already balanced, 1 on each side. My hydrogens are not. I have 4 hydrogens on my reactant side and only 2 on my product side. But if I put a coefficient of 2 right here in front of water, that will increase the number of hydrogens on my product side to 4. This also increased the number of oxygen atoms. So now on my product side, I have a total of 4 oxygen atoms. So my carbons and hydrogens are balanced, but my oxygens are not. And to get them to be balanced, I'll go to my reactant side and put a 2 right there in front of O2. When I do this, it will bring my count to 4. Now I am balanced. I have 1 carbon atom on both sides, 4 hydrogen atoms on both sides, and 4 oxygen atoms on both sides. Let's try one more, and this one's going to be a little more challenging, but that's okay, we can do it. Even if we attempt it and we don't get it correct, that's okay. It's okay to start over and try again. I wanted to point out how I've written the different elements. I specifically want to point out how I wrote SO4. So SO4 is a polyatomic ion, and notice that it shows up on both sides of the arrow, in the reactant side and on the product side. Since it appears exactly the same on reactant and product side, it's easier to just keep it together as SO4 and not break it up into its individual atoms. With that in mind, I'm going to take a tally of my reactants. So right now I have 1 aluminum atom, 1 SO4 ion. I have a total of 5 hydrogens and a total of 3 oxygens. Now I'm not going to count the oxygens that are coming from SO4. I'm kind of treating it like its own element. I'm going to do the same thing for the product side. So right now I have 2 aluminum atoms, 3 SO4s, 2 hydrogens, and 1 oxygen. This is where following the step-by-step guide that I had at the beginning of this video will be helpful. So we're going to start by balancing aluminum. I have 1 aluminum on my reactant side, and I have 2 aluminums on my product side. So if I put a 2 right here in front of AlOH3, that will increase my number of aluminums on my reactant side to 2. In the process of doing that though, I also changed the number of oxygens and hydrogens on my reactant side. So at this point, I now have 6 oxygen atoms, and I have a total of 8 hydrogen atoms. If you need to watch the video on how to count up atoms from a given formula, I would stop this video and take a look at that and then come back here, because it's awfully hard to balance chemical reactions if you can't count up the number of different types of atoms in a given formula. Okay, so now we've balanced our metals, the aluminum. Remember, we keep hydrogen and oxygen for last, so next I'm going to balance my SO4. I have 1 SO4 on my reactant side and 3 on my product side. So I'm going to put a total or a coefficient of 3 in front of H2SO4. And that will bring the SO4 count on my reactant side up to 3. This also changed my hydrogen count as well. So now I actually have 12 hydrogens. Okay, I still haven't balanced my hydrogens, so I need to do that. And so I'm going to do that by putting a 6 in front of H2O on my product side. That will bring my hydrogen count on my product side up to 12. This also changed the number of oxygen atoms on my product side as well, and actually in my favor, because now I also have 6 oxygen atoms. So now this is a balanced chemical equation. I have 2 aluminums on both sides. I have 3 SO4 units on both sides. I have a total of 12 hydrogens and a total of 6 oxygens on both sides. So that was a challenging equation to balance. But you did it. Great job. I hope that this video was helpful. Take care and be well.